so a conclusion can be made now is that as far as the coterminal angles, this is a general regulation here about the coterminal angles. So let's say for any, I'm going to call theta here is to be the angle that's within, theta is being within one rotation. Then you can make a theta plus 360 to indicate the same angle, but they are one complete rotation additional. And then we can have a theta plus 2 rotations. So measurements wise, it's 2 times 360. And then we can make another theta plus 3 times of the complete cycle, and etc. and etc. Or in radians, we can go theta is the original angle being within one complete rotation from between 0 and 2 pi. Then a coterminal, another coterminal of that is a theta plus 2 pi in radians. And then we can have a theta plus 2 times of 2 pi. Because keep in mind, I purposely want to display that 2 pi is counted as one complete cycle. So here, this is starting to be a multiple of a multiple of 2 of a complete cycle. And then continuing from there, we can have a theta plus 3 times of a 2 pi, and etc. etc. So that's how coterminal angles are being related. And these are, I briefly mentioned about those in the positive directions. And likewise, if your angle is being negative, so yes, still within one rotation, but this time additionally this is being negative. Then from where in the negative direction, then you can produce another coterminal angle from this angle here by being a theta but minus a 2 pi away. And then from where that is, we can go a theta minus 2 times of 2 pi, and you can go from where that is again. Additionally, we can make another theta minus 3 times of the 2 pi. And of course, in degrees, same idea again. Theta from where that was originally within one rotation, but being a negative angle. And then we go theta minus 360, and theta minus 2 times of the 360, and then theta minus 3 times of the 360, and so on and so on. And so, in general, really, coterminal angles can just simply have one relationship. All you need is just starting with any original angle being in, this is within one rotation. Either you can call it from 0 to 360 or between 0 and 2 pi. All we have to do is, from where that angle is, we are going to either add or subtract some multiple k of a complete rotation. So in radians, this is expressed as a k times 2 pi. So that's one way to generally express any angle on a unit circle and their coterminal angles. Or in degrees convention, once again, within one rotation, we have some original angle, and then all of those other coterminal angles in degrees are just simply a matter of either adding or subtracting some multiple of 360 degrees. Alright, so now that we have learned from the main video lecture explaining about coterminal angles that all coterminal angles, either in degrees or in radians, can have a general representation as the main angle plus or minus some multiple of 360 degrees of rotation, or in radians, the main angle plus or minus some multiple of a complete rotation 2 pi in radians. However, even so, there are multiple instances where you are working on a web-based assignment. But unfortunately, many of the web-based assignment systems, including the free ones or the commercial ones available out there, are not capable of handling or interpreting this symbol plus or minus sign. So in those instances, these formulas reduces down to the following. So instead of writing plus or minus, you just simply write angle theta plus some multiple of a 360 degrees of rotation, where k here is a variable that assumed to be either positive or negative. So k could be positive or k could be negative. Then similarly, this formula here in radians, the way how we write that usually reduces down to theta plus some multiple, some k multiple of 2 pi, where k is once again assumed to be understood to be either a positive multiple or can be a negative multiple.